Hey everybody, how's it going? Today in class we started something new. And so instead of posting the whole class link, I'm going to just walk you through a quick couple examples of what we did. Hopefully you'll join us next time for class. All right, so in our notes today, we are going to talk about adding polynomials. This is a new topic. Kind of builds on what we're doing with exponents, but it's a little bit different. Polynomials. There we go. Yep. So that just means adding like many terms or adding lots of numbers. How do we do that in algebra and why is it useful? So we talked about an example of a court, like a basketball court. Let's say we had this triangle shape. And let's say on the bottom, we had some measurement. Let's say this was 8b. And then over on this side, we had a measurement of 12b. Well, we discussed, can you find the perimeter of that shape? Well, sure, you can find the perimeter of that shape. The perimeter, there's a couple different ways to do it. The way I'm going to talk about is what we could do is we would find the distance all the way around the outside. So we could add these two together and then just multiply by 2 because they also show up over here. So I'm going to multiply everything by 2 after I add the 8b and the 12b. And that would give me my perimeter. So let me solve. This would be 2 times, what's in here, 20b. And so the perimeter around this is 40b. All right, so that should make sense to you. That's a lot similar to some things we've done before. Let's take that same rectangle and let's change one of the measurements over here. Let's say that we have maybe a court that's a little bit larger. The measurement over here is still going to be 12b. But let's say down here we had 6 parentheses. Well, you know, I don't like that 6. Actually, let's make it a 5. Let's say we had 5 parentheses b plus 2. And we talked about kind of what this could represent. It's the same b it was before. It's just now it's 2 something larger than whatever it was before. So if this was like, I don't know, 6 feet, then this might be 8 feet. So we're just adding 2 to whatever was there before. Now the question is, can we find the perimeter of this shape? Sure you can. It's the same thing kind of we did before, just with different numbers. So I'm still going to double whatever I get when I add these two sides. So I'm going to add 12b plus, and now over here I have 5 parentheses b plus 2. Ooh, I have kind of a double parenthesis thing going on over here. So I'm going to change those to brackets. Okay, so if I add these two together, then that should give me my perimeter after I multiply by 2. So now I go inside my parentheses here. So I still have my 2, but now I have 12b plus 5b plus 10. All right, so I distributed the 5. Awesome. Now I am going to add together everything in here. Now notice I only have these that are like terms. This is something different. This is a constant. So I can't combine that with these. So instead I get 2 parentheses. This would be 17b plus 10. And now I can distribute my 2 to both of those. So I get, how would that be? 34b plus 20. Now interesting, that's as far as I can go on my perimeter here. I'm left with a polynomial. I'm left with a 2-term polynomial. There's a 34b and a 20. And until I figure out what b is, I can't do anything else with the perimeter. I'm just stuck there. So this was a combination of multiplying and then combining like terms to get to my solution here. Now, let's take a look at another example. And let's focus a little bit more on the addition that's going on here. And it's kind of getting to the new thing today. Let's say we have some complicated kind of shape here. The shape doesn't matter so much. What does matter is the measurements I'm going to give you in a minute. Let's say we had this quadrilateral, so 4-sided shape. And let's say we knew some of the measurements here. Actually, there's a big piece we don't know, and that's going to be W. Whatever W is, the side length here is W. This one over here is going to be 3W plus 4. This side length up here is 4W squared minus 3. And this side length down here is 5W squared minus 6W plus 1. So I'm giving you just these numbers. You're not quite sure where they come from, but here's the shape, here are the measurements. The question is, can we find the perimeter? You notice a common trend? Yes, you can find the perimeter. All we have to do is add together all the sides. It's like we were walking around the outside of the shape. So let me write that out. And what I'll do is I'll just start here, and I'm going to just kind of work my way around clockwise. So I'm going to take W, I'm going to add 4W squared minus 3. I'm going to add 3W plus 4. And then I'm going to add, kind of fit it in the, squeeze it in here, 5W squared minus 6W plus 1. Whew, lots of things to add together now. All right, so I notice we have some like terms. We can only put the W squareds together because they are W squareds. The W's are a different kind of term, so I can put those together. And then I also have these constants, which are just numbers here that I will put together as well. So this is adding a polynomial. Adding, it was actually like 4 polynomials together. Let me start with you always want to start with the largest exponent ones first. So my W squareds. Now, when we were multiplying exponents, we had to add and actually change the exponent. With polynomials, since there's no multiplying, what we're doing is we're adding these pieces together. The exponent stays the way it is. If I have 4 W squareds and I have 5 more of them, well, that means altogether I have 9 W squareds. I'm going to cross those out because I added them. And then W's. We have 1 here, 3 here, and we're going to take away 6. So that's going to give me a negative 2W. That was 4, 2 away 6, give me the 2. And now I add my constants. Negative 3 plus 4 would be 1, plus 1 more would be 2. So the perimeter of this is this polynomial. And again, I can't combine, I can't do anything else with this because these are different terms. These are W squareds, these are W's, and these are just numbers, so they stand alone the way they are. I think that's everything you need to know for your lesson. We did a lot more in class. We had a lot of great discussion around this stuff and these ideas, but that is adding polynomials, and your homework is on Schoology. So good luck with that. Let me know if you need any help or any questions. All right, I'll see you guys next time. Bye.